In all of Chapter 2, it's all about equations, solving equations algebraically. So in 2.1, you're just starting off by writing equations. And in order to write an equation, you have to know the language that goes into it and all the words and vocab stuff. So here's a couple of different ways you might say equals. Is. And in red, you don't have to write this down. But if I were to say x is 5, then I could just sneak an equal sign there. Same deal here. X is as much as 5. X is the same as 5. X is identical to 5. And when you see actual sentences written out like this, most commonly you'll see the word is. I don't think these last three are going to show up very often. So in order to do these, you need to take these sentences and translate them into something that is an equation. So the clear, bold meaning in these words, I understand that. And I also understand the directions that basically echo the heading there. So my tip is to look for the word is whenever you read these sentences. And the reason I would look for the word is because just the same way we did the first chapter, where you only had an expression, you can break apart each chunk and figure it out a little bit more smoothly. So if I see the word is, I can just throw an equal sign to break apart the left from the right. So this red side that I have underlined says 5 times the number a squared. It's probably a little bit more normal for it to say 5 times a number squared. So that just means I'm going to take a number, square it, and then I'm going to set that equal to 3 times the sum of b and c. Well, the sum of b and c is b plus c. And if I want to make sure I multiply times both of those pieces, I have to make sure that it says 3 times that. So there's 5a squared is 3 times the sum of b and c. I'll zoom in a little bit better for this next one. This next one says 9 times a number subtracted from 95 equals. So scanning through, I find the word that is most similar to is. So something equals 37. Now I'm using the last part of the sentence first to make it a little bit more clear and easy for me to deal with the uglier part here that's slightly more confusing. So 9 times a number subtracted from 95. Well, I know that I have to do the subtraction part. So what does it mean to be subtracted from 95? Well, that's either x minus 95 or 95 minus x. And if I'm subtracting from 95, that means I begin with 95 and take away. So this is not the correct option. So here's 95 minus x. And if I want to do 9 times that, this would be inaccurate. I would have to do parentheses to make sure that entire quantity was multiplied by 9. Zooming back out just to kind of double check these. Does it say then solve it? It doesn't say to solve it, so at the end of this part we're totally done with problems 1 and 2 because we've done everything that they've told us to do, which is just to take a sentence and turn it into an equation. Let's look at real-world problems. Ice cream. Today, 2 million gallons of ice cream are produced in the U.S. each day. In how many days can 40 million gallons of ice cream be produced in the U.S.? Write and solve an equation to find your solution. Well, the confusing part of this is just deciding what's to be compared and what's equal. So looking only at the first sentence, you can get a highlighter out and highlight that if you want to chunk this. But 2 million gallons of ice cream are produced in the U.S. each day. Well, to me that means that there's 2 million. I wouldn't bother writing 6 zeros after that. every single day. So the unit of measurement that we're dealing with is like gallons of ice cream per day. And so if I multiply that by x, where x is the number of days, this gives me like how quickly we can get to a certain amount of ice cream. Well, in how many days will we be able to make 40 million gallons of ice cream? Now, you might be tempted to write 40x, so I'm going to write 40 here. But I will temporarily write x in red, meaning don't write that down. That would mean that after one day I made 40 million gallons. After 2 days I made 80 million gallons. So I wouldn't want to multiply by that variable. What I'm interested in is, after how many days of making 2 million a day will I get to 40 total? So I'm going to write 2x equals 40. Now if that seemed easy for you, awesome. And if I over-explained it, I apologize, but I think it probably is helpful. So let's look at the first command, write and solve an equation. We've only written it, so let's solve it too. Now for now, you probably would just be like, well, x is 20. So instead of doing anything algebraically or any way you've done it in the past, let's just write x equals 20 days. And we'll go ahead and box that, but let's check it too, because checking it helps real-world problems make better sense. Well, after 20 days, 2 per day, 20 times 2 is 40 million gallons of ice cream. We've written an equation, we've solved it, we've checked it, and hopefully the word problem makes better sense now. Same as before, this one probably feels confusing because just of the words. There are 50 members in the North Carolina Senate. Let's actually write that down. So here's the Senate. And the strategy here is listing what we know. Well, there's 50 members in the North Carolina Senate. This is 70 fewer than the number in their House of Representatives. Now here's the deal. This is their House of Representatives. It's not like we're comparing North Carolina to a different state. So let's just hang tight. Now the reps, we might be tempted to be like, this is 70 fewer. So let's be like, well, what if there were 70 fewer reps than there were in the Senate? Well, 50 minus 70 would be negative 20. So when I try to set it up that way, it kind of makes no sense. So let's see. This number right here, the 50 number, this is 70 fewer. So when we tag this, we'd have to say, well, 70 fewer than the reps. Now, hopefully the way I've written that down is, pretty clear. Well, maybe you immediately say to yourself, well, I guess that means it's 120. And we would be done with solving this. Now, here's the thing. If they only told us to solve a problem here, like just figure out the answer, we'd be done, and that would be acceptable. But these are not about this degree of difficulty of word problem. These problems where we're asked to write an equation are preparing us for way more complicated ones that you can't just simply solve through subtraction or through basic trial and error. So let's think about it. Well, if we wanted to write this up perfectly, well, we'd be like, well, the Senate is going to be equal to whatever the reps are minus 70. And I'm writing this out in words where we'd have total variables, because I think that might help you see that 50, well, we know the Senate, is equal to, I'll use y this time, minus 70. If this were a word problem where I was dealing with like speed or distance, I wouldn't use y. I'd probably use variables that, are the first letter of those words and go from there. So here I'll add 70 to both sides. Whoops, I'm sorry. It tells us to solve it, but we're just solving these through trial and error like we did. So let's label 120. Sorry for that. 120 members. Rereading through the problem and double checking it. Well, let's see. There's 120 in the House of Representatives, and 70 fewer than that would give us the 50 in the Senate. So we can double check it that way. I think we will wait before doing these more challenging problems in the second video. But if you're feeling very confident, jump right in. I'm just saying wait so that this video doesn't get too long. So this is the first of the group of videos for 2.1.